What's up, y'all? It's Hunter. Thought I would drop a video on the big debate in the fitness industry right now, which is high intensity interval training versus low intensity steady state cardio. So you kind of have people on both sides in terms of which is better for fat loss and preserving muscle. Though, technically, whichever one's better for fat loss is also better for preserving muscle, assuming you equate energy balance. So, in other words, if both groups lose the same amount of weight, whichever one's better for fat loss is also better for muscle growth, technically. So, there was a meta-analysis on the topic. It was from 2021. I think it was Steele et al. 2021. For those of you who don't know, a meta-analysis is at the top of the hierarchy of evidence. So a meta-analysis is basically a sum of all the data available from a bunch of individual studies, like randomized controlled trials. So, meta-analyses typically give us high relative confidence in any kind of hypothesis relative to other forms of evidence. So it was a meta-analysis from 2021. Basically, it added up all the data from a bunch of studies comparing steady state and HIIT cardio. And basically, what it said was for both lean mass and fat mass, when you equate calories burned, you get the same changes in fat mass and same changes in lean mass. So you get no differences in body composition, whether you do high intensity or low intensity cardio. Now, a lot of people in the fitness space, they'll kind of hypothesize one way or the other. So, for example, a lot of people will say that steady state cardio is better because you burn more fat during the exercise. And that's completely true. You do burn more fat when you're training aerobically and you do low intensity cardio. And the reason for that is because when you do higher intensity cardio, basically you have an oxygen deficit. You're not inhaling enough oxygen to rip off electrons from all the carbs, fat, protein, and nucleotides that you oxidize. So with more oxygen available when you do low intensity steady state cardio, at that time you will completely oxidize more fat into CO2. CO2 is going to exit the human body. It's going to go from high to low concentration. That obeys the second law of thermodynamics. And then that's going to pull fat metabolism towards oxidation. And again, that's just underpinned by thermodynamics. There's an equation in physical chem you can use to prove that. It's delta G equals standard state delta G plus gas constant times temperature times, I believe, the natural log of the mass action ratio of whatever reaction you're talking about. So this is pretty well known on a very deep mechanistic level, that if you have oxygen available, you'll burn more fat. And on the other hand, if you don't have oxygen available, you'll burn less fat, and instead you'll rely on anaerobic glycolysis to make ATP, and that'll help couple muscle contractions going against gravity. Without the oxygen, basically instead of oxygen being the final electron acceptor, pyruvate, which is an end product of glycolysis, it picks up a few electrons from NADH, which is nicotinamide adenine dinucleotide, plus a hydrogen attached to it, then another hydrogen, that becomes lactate. So basically, to simplify things, when you do HIIT cardio, you burn less fat during the exercise and you burn more fat during the exercise when you're doing low intensity steady state cardio. So when you look at this at face value, some will hypothesize on a mechanistic level that you'll lose more body fat in the long term when you do steady state cardio. However, as the data says, that's not the case. They're about equally as effective when you equate for calories burned. So you may be wondering, like, why is that? So this is completely underpinned probably by basically how metabolism is regulated in biochem. So let's say someone does low intensity steady state cardio, you burn up a ton of fat and you spare glucose. There are a couple mechanisms that you will then burn less fat post workout and you'll burn more of the carbs that you spared during exercise. So first off, there's what's called the law of mass action. This is a law of physical chemistry that basically implies that the rate of a reaction is proportional to the concentration of reactants. So if you burn, a lot of fat while you work out, you'll have less fat available to burn post workout. And if you spare sugar and glycogen during your workout from steady state cardio, you'll just have more of it available to burn off post workout. So you'll just burn more of it. Another mechanism in biochem, it's called allosteric regulation. Basically, different metabolites can behave as kind of feedback modulators. So for example, if you burn a lot of fat, you'll make a metabolite called malonyl-CoA that can allosterically inhibit an enzyme called, I believe it's carnitine palmitoyltransferase, so you'll burn, less fat post workout. On the other hand, let's say you spare a bunch of glucose. Um, Glucose, I believe it can behave as a feed-forward allosteric modulator for a bunch of reactions in glycolysis. Then you have covalent modification, which is just a very fancy way of saying you form and break chemical bonds with enzymes in glycolysis and fat oxidation. That can occur through the insulin signaling cascade and also through the glucagon signaling cascade. So as your blood sugar level changes, insulin and glucagon, they will catalyze phosphorylation and dephosphorylation of a bunch of enzymes and other proteins in metabolism. And I could get into more detail of that, but I don't want to waste your guys' time. And then the last mechanism is genetic regulation. And to kind of cut to the chase on that, your body will respond to whatever you do to it. So if you have a lot of fat available, either A, you didn't burn it during your workout, or B, you eat a lot of fat, you will start expressing enzymes and other genes that are responsible for you burning fat. So you will burn fat just because there's a lot of fat available. And that can apply to probably any metabolite, including carbs as well. So, you do low intensity steady state cardio, you'll burn, lots of fat during your workout. You won't have all these mechanisms going on to burn that fat post workout. And this is just how the human body accomplishes homeostasis. And we can just think of this on a much more simple level in terms of blood sugar regulation. So if you spare a lot of glucose during your workout, you're going to try to lower it by burning more of it post workout. You know, let's say you spare fat from oxidation because you do high intensity interval training. Your blood sugar is down, then your body will post workout spare glucose by burning up a bunch of fat. So that's kind of all the theoretical and scientific stuff about HIIT versus LISS cardio. So on a theoretical basis, they're equal. They're both effective on average. That is, because obviously research just points out averages. You may kind of deviate one way or the other. Maybe you kind of do better with HIIT cardio. Maybe you do better with LISS cardio. Because once again, science just reports the averages. So they're good to use as general guidelines. And on a practical level, LISS cardio can be useful because it doesn't cause all the, kind of DOMs that, HIIT does. HIIT has its advantages because it takes less time to burn X amount of calories. So there are good practical implications on both sides. Again, I think low intensity steady state cardio can be good if you just like walking, you just kind of like the outdoors. I think HIIT can be great if you want, I guess a little adrenaline rush to quickly burn up a bunch of calories. So again, there are good practical reasons to go, both ways. So yeah, overall, I think it's important to pick a form of cardio that you actually like to do, and also don't do cardio unnecessarily, because my input on cardio is I don't think it has a mechanism of causing fat loss independent of energy balance. I don't like we know that building muscle can just cause amino acids to partition towards muscle, therefore you oxidize less of those amino acids, then you oxidize more fat. So building muscle can, through a series of mechanisms, cause indirect fat loss when all else is equated. I personally feel cardio only causes fat loss through an energy balance mechanism. I'd obviously be very open to seeing data that opposes that, but I don't really see the need to do cardio if you're very active otherwise. If you're getting like 10,000 steps a day, I don't see the need to do cardio, but you can obviously do it if you want to. On the other hand, if you're only getting like, 2,000 steps a day from your job, I think there might be some practical implications for cardio just so that you can, eat a little bit more and, prevent yourself from gaining weight. So I hope that was helpful. That's kind of the theoretical and the practical side of, different cardio intensities. So on a mechanistic level, basically whatever you burn during cardio, you're going to burn the opposite thing post cardio. And practically it's all, cost benefit. HIIT can take less time out of your day, might be a little tougher to recover from. LISS probably would be, less impeding on your recovery, might take time. So there are good reasons to do both. I think best bets are to choose what works best for you, because thankfully the science says that both can work pretty equally effectively on the average. So that's all I got to say. Hope that helps y'all. If you want to see more videos, feel free to subscribe. Talk to y'all later.